what you have to do, yeah, so you can do like, that makes sense.
Yeah, let's wait for 1 more minute and then get started. Gilbert, do you have anything to present for the first item?
I might share my screen for the first item.
Okay. All right, I think let's get started. Gilbert, do you want to share your screen? I'm just going to share mine.
Oh, yes. Oh, okay. I find the button. Hey, morning, guys. So can you guys see my screen?
Yep.
Okay, so yeah, so for the first agenda item, it's about the Docker daemon handling issue. So it will be pretty quick, like 10 minutes, and then we'll hand it over to Jitao. So basically, we have the Docker daemon. So we fix an epic for the Docker daemon handling, and it is not a bug on Mesos. It is a bug on Docker daemon. So in production, so if the Docker daemon, like there are too many comments, go to Docker CLI, and some comment might hang forever, and this is a big impact on production because it will result in many different symptoms. For example, the task could never be killed forever, and Mesos will never know a task is running or not. So Mesos have no idea what the task status, and eventually it turns out to be there are a couple place we have to work around on Docker daemon to deal with the Docker daemon handling, because this behavior is not consistent. For example, sometimes the whole Docker daemon hangs, so it will hang forever. No matter Docker PS, Docker run, any Docker command, it cannot be invoked, be executed. And or another symptom, it is some of the Docker command, it does not work and hangs forever. But if you invoke the second time, it will work. For example, Docker inspect, the first time it just hanging there. And if you invoke a couple others, some of them might success, some of them might not. And there's a Moby issue, an open Moby issue on the Moby repo, and I think it was placed somewhere under this epic, but they did not fix it yet, so we have to work around this. And I believe we have this epic backported to 1.5, 1.4, 1.3, these three versions, and I believe it will improve the user experience greatly for people who use Docker daemon in production. Okay, let's take a look and what exactly they are. So the first one, it is the one from Fixed by Chen, and basically this is the issue about when the Docker container is already running, and Docker and once it finish or exit, Docker daemon could not capture the exit status of this container because of the daemon issue. And I think he linked a ticket on the Moby repo. So basically, once the Docker daemon could not capture, like the container is finished, so Mesos will regard the container still running. We have no way to do the status update with the scheduler. And instead, we implement and workaround. So we use the Linux rip to rip the PID of the Docker container. So once we have the exit status, we just return corresponding task status, like task finished or task failed, to Mesos scheduler, and then we will kill the. We will not rely on any any other information from the daemon. So because basically this what Docker daemon do, because in Docker daemon it also rely on Linux command to read the container PID. So because before this fix, we have a very bad situation if the Docker daemon hang on that, and then if our scheduler retry killing this task, it could not be killed because all the behavior rely on Docker daemon, or the container is actually killed or finished, but we just don't get the status update. So this is a workaround. It's already backported. I should adjust the fixed version later. It should be now from 1.3 to the latest version.
Just a time check, you have 5 more minutes.
Oh, okay. Okay, so the other one, it is about the fix we do together from Greg, myself, and Andre. And maybe I could introduce them all together. So Docker daemon could hang in any command, and Mesos rely on Docker inspect to get the handle of the container PID. So every time we want to get the handle of this container, we need to call Docker inspect. And Docker inspect is what's called in many places. For example, when we pull the image in Docker Containerizer before pulling, we call Docker inspect. In Docker command executor, we call Docker inspect after Docker run. So if any of this Docker inspect hands, we have no way to get the handle, so we could not do anything with this Docker container. So even if we call discard, we don't have any other we don't have any other update with this Docker inspect subprocess. So we change the library, which is done by Greg. So we support the discard behavior from, for example, if the caller of this Docker library called Docker inspect, we call discard. So in the library, we have a callback on discard to handle like all this promise for no matter Docker stop, Docker pull, or Docker inspect. We will make it a discarded future and return. So which means we will not have a pending future forever. We will return a discarded if the caller call discard. It is a lib process. It's kind of pretty lib process things, might be confusing. So we update the library, and then in the containerizer and the executor, we put corresponding fix after Docker run and Docker pull. So every time after a timeout, we will discard this future, and then we will return either failed status or discarded status for this particular Docker inspect, Docker stop, or Docker pull. So we will not end up with the situation in the containerizer like we are launching a container and then it just hanging forever there. So from the user side, user could always get back something from the container status. That's another thing. And the last thing we improve is from NJ. So we fix the Docker command executor. Also, we add some improvement. It is the retry logic. So we implement some loop in the Docker containerizer and the Docker command executor for the Docker inspect. So let's say if the Docker inspect hands, we will retry it again. And this retry gonna be forever. And so basically, the retry, it does not change the retry logic of Docker inspect in the command executor. It does not change any semantics before. It just improve the experience. So for example, like the first Docker inspect hands, we will retry again, and it's very likely for the issue if the Docker daemon hands for a couple time, it will address those issues. Okay, I think that's it. So any questions?
Can you adjust the fixed version to properly reflect which patch you have backported?
Yeah. I just backport all the patches yesterday. I just don't have the time to update the fixed version. I will update them today altogether.
Yeah. Make sure to do that so that they will show up in the changelog.
Yeah.
So did the changelog too?
I did not, but it is on my local patch already.
So you backport the patch, but you haven't added the changelog yet.
Because the changelog there are some conflict, I'm still fixing. So
okay,
I just don't have a chance to push it.
Okay, I see. Yeah, make sure to do that. Usually we do the backport along with the changelog update. Otherwise, it will be very hard to track those backports.
Yeah. It is already on my local patch. I just did not push yet.
Okay.
Yeah, so first of all, this is great. We actually see quite some Docker instability in our cluster to the degree that we're on the verge of giving up this thing. So I think this can increase the quality of what we offer to our internal customers in a short future. A couple of questions is, number one, are these improvements applicable to both Docker executor and the custom executor using Docker containerizer?
Yes. One of them might not be there yet, so might be the might be the first one, fix by chain. So this one, I realized the fix is for the executor only. We should do the same thing for the custom executor. But for all the other things, they are fixed on the library side or the containerizer side. So they should be sufficient for the custom executor as well.
Yeah, it might be good to. So secondly is like I don't think we have time to go over how the symptom, what the symptom would fix. But I think it might be a good idea to call out what kind of symptom people typically observe for the bug before the fix and after the fix. So they have a better idea to understand whether this bug has a good chance to fix the problem. I think the combination between agent and the Docker daemon is quite complex. The various combinations to the degree that few people in the world, especially outside the Mesos dev team, actually understands how to deal with all of them.
Yeah. I have a user experience doc on what symptoms they are for this Docker handling. They are different.
If you publish that somehow, that would be awesome.
Yeah. So I just before the meeting, I just don't have a chance to find it. It's hiding somewhere, one page doc, the Google Doc. So I will try to find it out and paste the link.
Oh sure, I think
link the doc to this Epic or any of the tickets will be useful for people to.
Or maybe just convert that into a. I don't know whether that should be a documentation of Mesos itself. We discuss on bug fixes in our own doc.
So we don't have that precedent, but
I think the end blog might be good actually. Even
I think a blog will be great. Yeah, I agree.
Yeah. Let me think about that. I think I agree. I totally agree. It was a blog, but for this ticket, each ticket we identify the root cause of each symptom. We just need another Google Doc based on this Epic, I think, to let people know what's the symptom from the user side, from the user, what user could see and what user could suffer, and if there's a chance and if we have time, I would be happy to help on writing a blog post about like how we improve the quality, how we work around the Docker daemon issue on Mesos. Yep.
Okay, that's awesome. Yeah.
Okay, so.
Just I have one more question. So are you guys using Docker container with custom executor?
Yes, Aurora.
Oh, I see. Got it. So the executor is running inside a Docker container.
Yes, actually we have, and that's that. And we also have another pretty big cluster running Docker executor too.
Okay, got it.
Almost every combination possible in our cluster right now.
Okay, I see. Got it. Okay. Because I think that part is not well tested. At least like we don't have any unit tests for that. So
yeah, but we just launched it.
The custom executor, because I don't think we have any. Well, we used to have one, but I think it's not fully. I mean, the code coverage is pretty low on that code path.
Yeah, I think if you can think of ways to improve the test coverage, so if you have tasks and you can almost assign them direct to me. I can figure out a way to improve test coverage on them. I'll find someone else here we have a couple of engineers interested in contributing to Mesos. That's a great starting point too, in my opinion.
Okay, that sounds great. Yeah, I think definitely reach out to me and I can point you the way of doing that. Okay, what's next? Zhitao, you want to talk about the Mesos 4965?
Yes. So this Epic is about, this issue is about allowing resize a person's volumes. So I think, do you want me to project the doc from my side?
Yeah, I think that would be great. So Gilbert, can you unshare and then let Zhitao share his screen?
Yeah, I think Zhitao, you can share now.
Yeah. Can people see the doc?
Yeah.
Let me enlarge it a little bit. So I think this is just about supporting resizing person volume. So person volume has been there for I think more than 2 years, and Uber is actually running a very big storage cluster using this feature. I think we are running one of the largest Cassandra installations purely on this cluster right now, and it's recently brought to our team's attention that because we cannot resize person's volume, what ended up from storage team is they allocate a very large volume size for every Cassandra ring, but in practice wasted a lot of disk space because of that. And to arrange these things around is extremely operationally expensive, and they don't want to suffer the downtime, say move to a smaller volume, do all the things that both make their framework complex, as well as possibly bring downtime to their customer. So they were really requesting, can Mesos support resizing of these volumes as long as the circumstance is safe? And I think this is something worth discussing, because this is actually translate to a lot of cost saving in our organization.
Okay, so I'm just trying to understand. So by resizing, so first of all, are you guys using mount volume or path volume?
We are using both, but I think the part they need is only the path volume.
Is the path volume?
No, we are simply creating persistent volume on the root disk.
Okay. And okay, I see. And then you want to resize that persistent volume so that, well, I think if it's sharing, are you enforcing disk quota?
Yes,
I mean, okay, I see. So the reason you want to do resizing is because you want to make sure that the quota enforcement is working properly. Because otherwise, they share the same disk, they can just easily go up their shares.
But even that, we create problem allocation because they are relying on the same resource allocation system.
Right. Okay. I see. Got it. Okay.
So I think from our side, the requirements, especially for the first phase of the project, the necessary requirement is we want to be able to decrease the size of a persistent volume. So and free up the disk resource so we can use it for other purposes. I think if we introduce this API for the sake of usability, we also want to be able to increase the size so that if the adjustment goes wrong and people realize they push too far, they can trivially increase the size a little bit as long as there are still disk space available on that machine.
Mm-hmm.
So I think in MVP phase, we can totally accept that both increase and decrease can only happen when the volume is not being used by any task or executor.
Mm-hmm.
That's what I mean, volume is offline. I think it simplifies a lot of problems.
Mm-hmm.
And like I explained, from our side, as long as the MVP covers the root type disk, we will be happy.
Mm-hmm.
I think the work should be easily extendable to path disk, if my understanding is right, because they don't differ that much.
Mm-hmm.
I think the mount disk resizing seems quite tricky because that's actually it's a different thing in the mount table. So we are not actively seeking for that. But if people think that should be included in the requirement, we can revisit.
Well, yeah, I think mount disk totally depends on the backend. Like for example, decreasing is most likely not possible in many of the file systems. Like you cannot simply just say, hey, I want to remove some of the disk space from that virtual disk.
Mm-hmm.
I mean, expanding is possible with something like LVM.
Mm-hmm.
That you can increase the size of a logical disk, and then that can just essentially increase the size of the persistent volume. But decreasing is going to be hard for mount disk.
Okay. Let me say this is outside of MVP scope at least.
Yeah. Okay.
Sorry. So I started a quick document, quick work in progress design doc to capture seems like what's needed across the stack to make this happen.
Mm-hmm.
I think the first thing I want to discuss here is what the API should look like.
Mm-hmm.
It seems like the reserve and unreserved API right now is incremental. So for example, what I mean is if we have 1 gigabyte of disk reserved on this machine,
mm-hmm.
if I want to make the total reservation to 2 gigabytes, I submit
mm-hmm.
another reservation 1 gigabyte.
Mm-hmm.
Instead of say, I want a total reservation of 2 gigabyte here. So that is why I list out 2 alternative API direction.
Mm-hmm.
One would be describing a grow or shrink of the delta part.
Mm-hmm.
And the other would simply be an update message describing the total size of the volume.
Right. So yeah, I was thinking about similar, like I think I was thinking just like adding a new framework offer operation, maybe like resize volume, like a grow volume or shrink volume. And that operation should take the original volume and plus some additional disk resource where the additional volume size is going to be coming from.
Yeah.
And they have to be reserved on the same row. Otherwise, master will just reject those.
Yes. Yes. Yes, that's exactly what I'm describing in the first topic.
Right.
And I think similarly, we'll just add similar things to both the operator API and HTTP endpoint. Well, do we still want to backport these changes to HTTP endpoint?
What do you mean by HTTP endpoint? Oh, you mean, we stopped doing like V0, like pre-V1 operator APIs. So yeah.
Probably will cross this out, but I think it's trivial to add it if you want, but.
Yeah, I mean, we try to not to do any change to the V0 and encourage people to use V1.
Okay. So I think implementation-wise, this should not be hard, especially after recent changes of both CSI and its agent reconfiguration, because resources can already change. A lot of resources can already change.
Mm-hmm.
I took a quick look at the code to understand what's necessary. Seems like changes on agent side seems almost trivial in that master simply needs to send a new checkpoint resources message and let the agent apply it. If we believe the volume is offline at that point, then everything is fine.
Mm-hmm.
Yeah.
Yeah. So I think implementation-wise should not be too hard once we figure out the API. I mean, there might be some tricky cases, like what if the row doesn't match, something like this.
Yeah, I think it seems like more work will be on the validation side than actually implementation side.
Right. Yes.
Yeah. So I think a tricky corner case is if we decrease the volume size to the usage, like for example, if the database left 10 gigabyte of data on the volume, but we are shrinking it to 5 gigabyte, what does that really mean?
Yeah, so that's the tricky. Like, why do you guys need to shrink the size of persistent volume?
Like I said, for example, our Cassandra team, I think they gave out because they don't know how big the database is when they launch the product. It's very hard to gauge that. So they give everybody a 2 to 5 terabyte of volume space. But then a lot of products end up smaller at the end of the day. So they say they probably need maybe 100, 200 gigabyte in stable state. Cassandra has a behavior, they need double the disk space for snapshot. So the absolute necessary they need is less than 500 gigabyte. So they say they want to launch it, let it stable, and then say, okay, let's now shrink back the space so they can free up for other usage.
Okay, got it. Okay, yeah, I think as you mentioned here, I think one issue that I can think of is I think for DU-based isolator, it should be okay because it should be okay. It should adapt to the new resources. But I think for XFS-based isolator, we need to be extra careful. I'm not sure if that's supported right now.
XFS is not supported yet. I think someone just called it out yesterday for me.
Yeah, that was me.
Oh yeah. Hi.
Okay, so persistent volume is not supported for XFS. Okay, I see. Got it.
Yeah, I think. And I think as long as this is offline, it should still work.
Yeah, I think right now I simplify the problem because you require an offer to be able to do resize. That means the volume is not being used by anyone when you're doing grow or shrink. So I think that simplifies the problem.
Yeah.
Okay.
So one comment here is some of the we probably should think about adding a capability for a capability for shrink. That's sorry. So adding a capability for shrinking. So which would be determined by the actual the implementation from the persistent volume. Would that be a consideration?
Yeah, I think like moving forward. So this is just for agent. The resources, disk resources provided by agent directly. I think given that CSI is being introduced, and we do have CSI support for local volume, like it runs something like LVM right now. So moving forward, if you want to do resize for a CSI back to volume, then the CSI plugin should give you information about whether it supports resize or not. For example, LVM support resize, so it should support like row at the very least. Shrinking, I don't know. Maybe it doesn't support. But yeah, I think we probably need to discuss with CSI community on that too, see if they're interested adding a CSI interface called like resize. I'm pretty sure they're interested because I see discussion on that previously. And to make sure that the CSI backed volume is also supporting those new alpha operation like shrink or grow.
Right, and adding like a primitive for capability of sizing, and this would be helpful to identify whether like one volume would do that or not.
Yeah, it's up to ultimately it's up to the backend to decide whether they have the capability to do shrinking or a grow. And I think the question is, how do we expose that information to the framework? What kind of API are we exposed to the framework about that capability? Right now, we don't have that mechanism, but we need to think about that. But at the very least, you can reject if you don't have that capability. Like, yeah.
So a question about a high-level question between persistent volume and CSI. There is no current plan about the changing persistent volume to be backed from the CSI interface yet, right?
So sorry, say that again, Jita.
So persistent volume will still have their own API in the short to mid-term future. It's not going to be required to go through the CSI.
No, I mean the persistent volume API is totally orthogonal to the like create volume, delete volume CSI related API. Because once you create a CSI, I mean the CSI volume just like create volume from a pool of storage, and then whether you want to use that volume as an ephemeral volume or persistent volume, it's another decision you have to make. So these two are totally orthogonal.
I see. Okay.
So Ian, we cannot hear you.
Can you hear me now?
Oh yeah, that works.
So just two things. So I was trying to chime in when we're talking about even for disk DU about downsizing and the size of the data on the disk is already larger than the size you're trying to shrink to. Even if you have DU, you cannot prevent other tasks, other containers from being prematurely limited because of the shared disk, right? Because if you downsize your disk and you're not launching a container, but someone else thinking they have a larger space, but then they could run into a situation where they actually don't have that space.
Are you talking about shared resources? Like
no. So let's say if you're on a path disk, you have two path disks sharing the same physical volume.
Yeah.
And you shrink your volume 1, but you've left more data on the disk than your persistent volume. Then you're affecting the persistent volume 2, which is on the same physical disk. So then another task using the other volume cannot actually write to the same amount that it's offered to it, right?
Yeah, I think my understanding is we already have that issue. Even right now, we don't have any grow or shrink capability. We still have that issue right now, given that the DU-based isolator will still allow the disk usage of a container to go over quota.
You're saying while it's not in enforce mode, or
even in enforce mode, it's possible that the container that use the persistent volume will go over quota, because DU is based on time, and the time you do the check is if it's later than when you write a disk, then you might still go over quota, and your container will be killed eventually, but the disk space you're using for that container is still go over its quota. So that will affect other containers' quota.
Right. Well, that will be basically as a result of a race condition, if you will, if it happens during the period.
Yeah.
But this could be a long time, right? If the framework just stopped launching any tasks and goes away, it will be just basically staying that way.
Yeah, I think ultimately, I think that the path-based disk is very hard to. I mean, unless you use something like XFS to strictly enforce the quota. I don't know, like even if in this case, like how do we reject the shrinking if the disk space used by that container on that particular volume is already go over quota? Like, what should we do? So that might be something we should think about.
Well, if you have explicit feedback for the current set of offer operations, then you could send that back as a failure to downsize, right?
Yeah, but that means agent needs to get the information of the usage of that disk somehow in some way. Right now we don't have that mechanism. But yeah,
would that be as simple as a do when it's doing this operation on the agent?
Yeah, we can do that. It just okay. Yeah, I think that might be one possibility, to just do a DU when you actually do a shrinking or just additional checks, and reject the operation if it's not under quota. Yeah,
Cool.
so that's a good
just
point.
Something to think about. And
right.
And XFS, it's not in it right now, but logically it sounds it would be only natural to support it.
Yeah.
But I think it's not that different than supporting all of the cases we have to consider for disk DU.
Right. Yeah, that's a good point.
So for the CSI backed operations, so if I understand correctly, like you said, it's orthogonal.
Mm-hmm.
But it's related in the sense that, I guess, because they perform operations on like the raw resources,
mm-hmm.
which persistent volumes are created on top of, right?
Mm-hmm.
So it feels to me kind of means you have the possibility of like doing two kind of resize to achieve one purpose. Like if you create your persistent volume on top of a LVM, and then you have to issue two operations. First, you have to increase the size of the LVM volume, and then
mm-hmm.
another operation to increase the size of the persistent volume on top of the LVM volume.
That's one way to think about that, but I would rather think about that as just one operation to expand the volume. I mean, persistent volume to me is just like a additional ID information and label on top of the existing volume. So what you're really talking about is the one that has the storage is actually the underlying volume, and the shrinking and the grow is actually for the underlying volume. Persistent volume, you just think about that as a label on top of that volume, that so the firmware can get that information and point to the same volume when the task being restarted. If you think about that way, there's only one backing volume, so there's really one grow or shrink operation on that volume.
Well, can you have two persistent volumes on top of the same LVM volume?
Can you have two persistent volume on? Oh, not the mount volume. So if you expose the LVM as a mount volume, then you don't have a way to do that.
Okay. You can also expose that as a path volume. Right?
You can expose that as a path volume. Then essentially it's. Oh, I see. You're saying like it's for path volume that since it's shared, then you have another layer on top of that. I see.
Yeah, sounds like many cases and possibilities.
Yeah, so path volume, but I think it's related to whether it's path or mount. It has nothing to do whether it's persistent or not.
Intuitively, seems like not so safe from my point of view. But like I'm not sure. Like the long term, we should also detect like the cardinality for this kind of things.
What do you mean by cardinality?
Cardinality. So, for example, like LVM being used as a persistent volume, then again, it's being used as a path volume, and it's being shared.
Well, right now it's up to the framework to decide whether you want to carve a LVM volume group into either mount or path volume. So that's the framework to decide. Depends on whether they want to share the space from that virtual logical disk or not by multiple volumes.
Yeah, but like again, so like this would lead to like some sort of conflict or like a reuse of those volumes not in the really not really like in the desirable state, right?
Sorry,
So,
I don't follow.
Like again, so it's just like you're sharing the same root disk, and sharing like the same quota, and then there could be raise, and then causing one unexpected behavior. Yeah. So I mean, just throwing up a point here, and
okay.
yeah. So I mean, like I'm just not sure. Like going forward for a longer term, this like cardinality detection would be a point.
Okay, I see. Okay.
I would rephrase this in a different way. So especially in a very complex cluster, when there's multiple frameworks and multiple workloads sharing one really large resource pool, which is the intention of how Mesos should work. So what we observe in practice is that I think it's technically possible for every framework to do the right thing. But when you mingle code from different written by different organizations or different open source projects versus closed source project, they don't always ended up all compatible with each other on the framework level. So that is like, in many cases, I feel it might be better as the operator to make pre-arrangements for these things. And then simply say, now when you launch your framework, you don't really need to do these reserve or create volume things. A volume should be there ready for you. If not, instead of directly interacting with the Mesos layer, interacting with a very thin shim of API server, which will make all these things available for you.
Yeah, so that's what we do in DCOS. So in DCOS, we have this centralized controller to actually responsible for creating those volume. And then we introduce this concept called profile, which is essentially similar to like Kubernetes storage class. Yeah. You can distinguish multiple disks based on their attributes and parameters.
I see.
And the framework will just pick those disks based on the profile name of those disks. Yeah, so that's what we do in DCOS, and there's a centralized component that are actually responsible for creating those volumes. So framework don't do anything. They just.
I think that seems we are not using DCOS now, but that's like a more manageable solution.
Yeah, I think that you guys can do the same thing. Just have another framework that's as a central point of creating those volume for other frameworks, and then there can be CLI interact with that controller framework to create persistent volumes.
Yes.
Hello?
I like that approach.
Yeah.
Hello?
Yeah, we can hear you.
One idea to address Yan's question about increasing the size. I think we can unify these two layers, the backend volume and the persistent volume on top of that, because we always need to first calculate. So when we receive a resource, maybe it has a path volume on it, and we want to calculate the number of disks, like the amount of disks used. But we also want to compute. We probably also can compute the number of available space on the same backend source. So when we try to expand the volume, we can first try to utilize the free space on the same backend source. Then if there's enough space, then we don't need to query the backend, say CSI backend, to expand the volume, the physical volume. But if there's not, we use up all the free space, then we go back and query the physical backend to ask if I can do a expansion on the actual backend. How's that?
Yeah, so yeah, I think we should definitely do some design, because I think this is pretty early stage right now, and there's multiple ways to do that. So yeah, what you said is one way. I think the other way is just like don't ask. I mean, there's some other ways to do that, where you always model the free disk resource as resources, and then when you do create volume, you have to specify which additional disk resource this new disk space is going to be coming from. You have to do that in the operation itself. Okay, anyway, I think we should not discuss the design here. I think we should follow up with another design. So this is a good start. So Zhitao, what's the timeline
I mean, ideally, we want to see this happen as early as possible, probably targeting 1.6 if that is technically possible.
Do you have engineers that can work on this?
Yes, I will work on this.
Okay. Okay.
Yes, this
Okay.
is my top priority in my development queue. So as long as I can find the shepherd and review the change, I will. This is my top priority about the Mesos development.
Yeah, I think Chun, since you're quite familiar with that part, so that's something that you can help with Jital, and you guys can design together on this.
Yeah, sure.
Okay, sounds great. Yeah, I think the follow-up item is you guys just think on this and then come up with a design doc so that we can discuss again during the working group meeting in the next month or next 2 weeks, so that we can decide what to do next. Okay, so I think just a time check. We still have one more agenda item, so I do want to get to that. So let's go to that discussion.
Okay, stop sharing. Thank you.
Okay, so let me see the skin. Harold, are you there?
Yep, I'm here.
Okay, do you want to share your screen to discuss the design doc for the XF software?
Yeah, let me just pull up the doc first. Okay, shoot. So, and share screen. And I only want to share this one. Okay. Okay, so everybody can see this, I'm assuming?
Yep.
Okay, excellent. All right, so just to give you a little bit of background, previously we were using the disk-DU isolator that we were talking about previously. The problem that we have, and it looks like others do as well, tickets mentioned here, but basically there is a, like when the hard limit is set, the current functionality of the diskfs is that when you set a limit, it understandably sets a hard limit. And so the result of that is just that your application will try to allocate space, and most applications don't actually handle the end of quota error correctly. So they just sit there and do nothing useful. They may be complaining, but because you're out of disk space, well, you don't really know. So there's a couple ideas that we have, and it starts out with providing a sort of headroom. So, and with this headroom, essentially whatever the user, so if somebody is using Marathon, which is the case that we have, what you would do is just say, whatever amount people request, make the soft limit be that requested amount, and then provide an offset such that it can be, at a global level, you can say, okay, well, we want to provide, it can be something as small as like 1 meg, it can be 10 megs, it can be a gig, whatever for your place you would want. But what this enables is now your applications can actually go over said limit, which in most cases might be fine. And as a result, you would be able to create a kill switch as well. So if there's going to be applications that might go over, that's fine if they're teetering along that line. And depending on how you have your quota limits set up, you may not need to worry about this at all.
I have one question. So when you say talking about soft limit and hard limit, from resource allocation perspective, should we use hard limit to do resource allocation and allocating, or using soft limit?
I guess how do you mean?
Like, for example, like from Mesos standpoint of view, like you have a bunch of disk on the agent, and Mesos just allocating those disk resources to every single framework. When Marathon, for example, as a one framework, accept an offer for and he wants to use a disk, and the user of the marathon actually set a soft limit on the disk requirement, let's say 1 gig, and let's say the hard limit is like 1.5 gig. So from allocation perspective, do you actually take 1.5 gig and to reply to the offer say, I want to use 1.5 gig, or you say, I only need 1 gig?
Yeah, so it would still be, the functionality would still be that you are reserving that higher limit. So that part wouldn't change. What this would enable is somewhat a little bit obscured from the user, right? Is I want to use, if I'm asking for 100, I'm possibly getting more than I'm asking for, but that's because at the level of providing offers, you want to, like from a resource perspective, you obviously want to only allocate as much as you have available. But this allows the slack on the applications that are running or the containers that are running.
So if I understand correctly, like say the user is asking 100, and Marathon will ask Mesos for 150, and like the 50 being the headroom, and you want to enforce the quota at 150 as a hard limit, and the soft limit is 100. Like, is there a way to enforce soft limit in XFS?
Yes, there is.
Okay.
And so this is something that's built-in functionality. So I've actually started a little bit on a POC, just to try to prove it out. And I have it to the level that I can set soft limits. Right now, I'm just using a default. So in here, there's the idea for flags that I have is you have a hard limit offset, such that any request, whatever they ask for, default is 0 to provide, functionality as people expect right now. So nothing changes from an interface perspective. But if they want to set it, then they can set it above. And then there's also the 2 other flags that are related to actually killing the applications that don't want to, or killing the applications that are over their grace period. So in XFS, there is actually an ability at the project level to set a grace period. Default is 7 days, that is the standard. So this would just be a false that, basically all of these are work as you do currently. And so once you enable this and this, what's up?
Could you remind us again? So forget about Mesos for a second, just the behavior of XFS, of soft limit and base grace period and the hard limit.
Okay, yes, of course. So XFS at a base level has 3 potential ways, depending on it. At the latest version, has 3 ways that you can do quotas. You can do it at a user level, you can do it at a group level, and you can do it at a project level. For Mesos itself, we're using projects, so that's what applies here. When you set a soft limit, it is something that then starts off a timer. That timer is going to be based on what grace period you decided on for your application. The grace period is by default 7 days, and what happens is after that 7 days ends, your soft limit becomes a hard limit.
Okay.
So the grace period essentially, you can set it down to a minute, which is what I've been doing for my testing purposes. But once that grace period is over, then it will block you. And when you're violating that, so if you're trying to query from a API perspective, when you're querying this information, the way that it's represented is actually an epoch timestamp. So regardless of, so as soon as the soft limit's broken and XFS knows about it, when you query for that, that field is that grace period field is filled with the time that the grace period is now over. So, if it's right now it's 6:55, you've just now broken your limit, so it'll have it for 6:56. And once 6:56 occurs with this particular flag turned on, it will actually create a container limit and will kill the application at that point.
Right. So the goal for this change is, so I'm wondering, so what the behavior do you want
Okay.
when the task is between the soft limit and the hard limit?
So when it's between the soft and the hard, essentially it depends. It's time based, right? So if you're within that grace period, nothing should happen. It should function exactly as expected. Your app can use all the way up to the hard limit of space. And, unfortunately, fortunately, if your app is still growing for whatever reason, like beyond whatever even beyond that extra, it's not going to fill up your disk space. So you're safe in that aspect. But if you have, if you've then used up your grace period, and you haven't met your soft limit, you're now blocked from using more space. And as soon as the watcher, as soon as the mechanism that checks sees that you have violated the grace period, it will kill it with that container limit. Actually,
so the ultimate goal for you is to kill it, right?
Yes.
And that's not achievable when you only have the hard limit?
Correct. Well, it is, but then you get into this weirdness where somebody, because you could technically have that hard limit be enabled, right? But then you could have the hard limit enabled. However, you can never break the hard limit because it's a hard limit, right?
Right.
And so then you have to have some way of saying, sorry, go ahead.
Then will the behavior be that it will go basically to the exact limit?
That's not always possible because the problem with how that is it's based on how much your application is trying to allocate at a time. And if it's over, so if you're at, just use simple numbers, we're at 100 again, and you are using 99, but you want to allocate even 2, then it will just deny that allocation right off the bat. So you'll never actually get to that limit because you're asking for 2, and I only have 1 available. So you'll never actually reach that limit. And we do have kind of a hack. We have a wrapper that basically happens whenever any application runs in Marathon. And it basically starts up its own thing and basically says, if you're at like 99%, then kill it. But we want to provide people the amount of space they're asking for. And really, if they're going over that, then we know that, hey, they're not doing something that they should. And we have certain applications that are back and forth in terms of how much they use. So maybe, and this comes into the second half, is potentially setting up to have soft limits that are to have soft limits that are customizable per container, so that you could have disk is what it is, right? And having some sort of soft disk limit asked for, so that even if you have this hard limit offset, whatever you have here in this case, if I ask for 100 and I actually ask for some soft disk limit under that, then I will get this functionality. I think that this table actually
right. So I think so that customizability is because you would think, so yeah, if we have that kind of limitation, then what if you have a set soft limit, but then your user application actually try to allocate beyond that range? So it's like, no matter how much the gap is, you could always like try to allocate a wider gap, right?
Right.
So,
and so we want to have some sort of individual, like we want to have a global rule for the purposes of, well, most apps don't really care. They're probably going to use some amount, but this at least provides a mechanism for them knowing why their application's not working. I was actually subject to this before, so I'm working on a team temporarily to help with this specific issue. But I had a application that I started in Marathon, and I didn't even know what the problem was because it couldn't get past starting up the application. Like I couldn't start up the application because the file that was being executed was bigger than, what was bigger than the space that I had requested unknowingly. Like I didn't know how big my actual executable was at the time. And so I went to try to run it and it would just die. And I had no explanation for why it's happening. So this would help alleviate some of those sorts of issues, as well as others.
Yeah, I think we're almost out of time. But for that, yeah. I just have a short comment, which is, if you're the implementer of the framework, like you think, well, I can customize it, but then ultimately they are the different group than who's writing the end user application, right? So not always that the framework will be able to set the limit for that end user application. So empirically, it's just, to me, I don't know whether how wide of a class of problems this can solve, or really it's just you have this one framework that's specifically for this one application. I think that might work.
Yeah, anyway, I think this is kind of additive to the existing functionality. Yeah, I mean, and does solve some of the use cases that you guys have. I don't see any problem implementing this if it's not too complicated. I assume it's not too complicated.
No, the POC was relatively simple. More or less, currently the XFS isolator does not use the watch.
Yeah, so that's why I figured that you probably need to implement that one.
Yeah, so that's been implemented, or like in my POC, I've implemented that, and then there's an additional function that is called asynchronously from the watch, and then on a deferral continuously. Yeah,
so one suggestion I have is like, I think no matter what change you did, to make sure that the people can still use the old behavior, like so that they can choose to use the new behavior or use the old behavior. So
right,
because the old behavior, the container won't be killed.
Yeah, everything that I've been trying to add in here would have default, so the offsets default to 0. So essentially, if you have a disk limit, or if you have your hard and soft, if you don't have a hard and soft, then and you don't have this set to anything but whatever the default is, that will function as it does currently.
Okay, so the watch won't be triggered.
The watch won't be triggered.
Okay,
the watch won't be triggered because of this one.
Okay, I see. Yeah. Okay, so I think who's going to shepherd that work? Have you talked to anyone that might be able to shepherd this work? I think either ENX or James Beach.
Yeah, I started talking with James Beach.
Okay.
So if I can get, if I can work with him, that would be good. So
yeah. Okay. Unfortunately, he's not here, but I think you should reach out to him. I think he's the one that wrote the original XFS isolator. So reach out to him and ask him to review those patches. Will be great.
Okay. So one question I do have is in terms of submitting the patches, is it through? Because I don't currently have a Garrett account. So would I just do a Git email and send them to him that way, or what is?
I think we do use Apache. So there's a doc site about there's a doc about how do we contribute catches to Apache Mesos. So the typical tool we use the Apache review board, but GitHub also works if you prefer that.
Okay, yeah, either way is fine by me. We use Garrett a fair amount, so
okay,
no problem.
All right.
Okay, awesome.
Sounds good. Thanks. All right, I think we are over time. Let's wrap up here and see you guys in 2 weeks. Thanks, guys. See you guys.
Yep, appreciate it. Bye.
Bye-bye.